Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4, part B, or part 2. This is question 4, part 2, from the May-June 2022 IAL, kind of IAL, 9709 syllabus. This is from Pure Mathematics 1 of Cambridge. And this question here is about integration, actually. Although this is in my end of topic worksheet for differentiation with the rest of the question, but this is actually about integration. So I've saved this as a separate video, and I'm going to stick it in my integration playlists. So it says here, a curve is such that dy dx equals 12 over 2x plus 1 all squared, and P15 is a point on the curve. Find the equation of the curve. All right, now there are two ways we can go about doing this, and I'm going to show you both ways just to make it a bit more complete. So one way of doing this is we can say, okay, to find, if we know dy dx and we want to find what y is, we have to integrate. So y is going to be the integral of what dy dx is. So it's 12 over 2x plus 1 all squared with respect to x. And if you want to integrate this, okay, you can basically rewrite it as 12 times 2x plus 1 to the power of negative 2, and write that with respect to x. When you integrate or differentiate, you have to prepare the expression for integration or differentiation. Any variable in the denominator, in all the cases that we're going to deal with in AS Maths, you're going to write those in the numerator with a negative sign. Now it's like this, we can do what's called reversing the chain rule. Okay, now this is something very important. Now in AS, nearly every example that you're going to see will be such that you can reverse the chain. But in A2, there might be some cases where you can't. So it's good for you to understand the reasoning behind why something can be integrated by reversing the chain rule. Now, the chain rule is when you have a function and you have a function inside that function. Okay, when you differentiate it, it's like you differentiate the main function, okay, and then you multiply it by the differential of what's inside it. So when you see something of this form, then you can reverse that. Okay, you can reverse it. So when you see something which is differentiated and then outside it is when something is basically multiplied by the differential of what's inside the function, okay, when something is multiplied by the differential of what's inside the function, then you can reverse the chain rule. So if you see here, outside this function is 12. Inside this function is 2x plus 1. If I differentiate 2x plus 1, I get a constant. Now this is also a constant. I could write this as 6 times 2, right? So it's like this is being multiplied by the differential of what's inside the function, okay, or something of that same order, okay? It's a constant. So in this case, I can reverse the chain rule. If this said 12x out here, I couldn't do so, because if I differentiate 2x, I don't get something x. If you said 12x here and it said 2x squared here, then I could. Why? Because if you differentiate 2x squared plus 1, I get something x. All right, but in this case, if I differentiate 2x plus 1, I get a constant. Outside it here is a constant, so we can reverse the chain rule. So once we start reversing the chain rule, what we do is we get rid of the integral sign, we add 1 to the power, and then we divide by the new power, just like we do with integration. So we divide by the new power, and then we also divide by the differential of what's inside the function. In this case, if I differentiate 2x plus 1, I get 2. And then we put plus c. Don't forget the plus c. So this will give us y equals, now the 12 divided by minus 2 is going to be negative 6. And I can rewrite this as 2x plus 1 to the power of minus 1, which is like just 2x plus 1. And then I can put plus c. And now I can use the point P. Now the point P has coordinates 1, 5. Okay, that's a point on the curve. So I can use this point to find what c is, and I've got my equation. So when P is 1, 5, I can find what c is. Well, how? Because I can replace the y with 5, and I can replace the x with 1. So I have 2 times 1 plus c. So 5 is equal to now minus 6 over 3, which is minus 2 plus c. So c is equal to 7. So I can now write my equation. I can write the equation as y equals minus 6 over 2x plus 1 plus 7. Okay, once you found the value of c, you have completed the question. Okay. So there we have the answer. Now, as I mentioned, there's also an alternative way of dealing with integration. Okay, and I'm going to just go through that in this part here. So I'll start at the top here in case I need some more space. Now, if you understood what we did there, then it's absolutely fine. You don't have to worry about what I'm doing next, but this will help you for later on in terms of doing things called differential equations, which come later. But the concept is something that, you know, important, I think. So we want to basically, we're starting off with dy dx equals, and I'll write this, so it's already 12 times, as we said, 2x plus 1 to the power of negative 2. What I want to do is, I'm going to integrate both sides with respect to x. I'm going to integrate both sides with respect to x. Okay, so basically, just make a bit of space here. If I integrate this side with respect to x, and I integrate this side also with respect to x, you end up with the integral of 1 dy, integral of 1 dy, okay, equals the integral of 12 times 2x plus 1 power of minus 2 dx. Okay, now what we can do here is we can use these and we can use definite integration. So I can say I'm trying to find what y is in terms of x, and I know that when y equals 5, x equals 1, because we have the point P, 1, 5. This is the x value, this is the y value. Okay, so now when I integrate this, I'm going to get y. I'll have my limits of y and 5. When I integrate this, I put a square bracket because it's a definite integral. And as we did before here, we end up with minus 6 over 2x plus 1. So it's the same process we go through here. I'm just skipping that section, giving you this. I don't put plus c because I have a definite integral, so I'll put x here and 1 here. And now I want to find, I don't have to put the plus c. This will automatically find the plus c for me. So all I have to do now is put y in here. So I have y minus, put 5 in there. That's 5 is equal to, put x in here. So you have minus 6 over 2 times x plus 1. And then you're going to put minus, and then you're going to put 1 in here. 1 in here. So you have a minus, that's going to be 6 over 2 times 1 plus 1, which is 3. So we end up with y minus 5 equals minus 6 over 2x plus 1. And that's going to be minus, which is plus 2. We add 5 to both sides. So y is equal to 6 over, negative 6 over 2x plus 1. And 2 plus 5 is plus 7. So you see we get exactly the same answer. But in this case, we didn't have to put plus c. Putting these limits gave us the c kind of like automatically. Right, so that's an alternative way of continuing on from here. Okay, so this is something like linked to what we're going to take later on, which is called differential equations, and it's a good idea to understand that process. So there's the answer to question 4 part 2, okay, which I'm going to save in the playlist for this paper. Okay, so other parts of this question, other questions from this paper that I might have answered, you'll find in that playlist. And you'll have the playlist for the end of topic worksheet number 11 on my P1 collection, which is differentiation 1. And this is part of that question. Question number, in fact, it's question number 9. This is question number 9 from the actual paper. Okay. And you'll find the other questions from the end of topic worksheet here. Other questions dealing with integration in P1 you'll find in this playlist. And you can subscribe to my channel by clicking on the link over there. Thank you for watching and see you soon.